In the previous videos, we talked about absolute and effective pressures. The effective pressure, or in short, the pressure, is the one that we use in almost all our practical applications, and it's equal to the difference between the absolute pressure minus the local atmospheric pressure. It's important to make this clear. When we say pressure, we're referring to effective pressure. When we're dealing with absolute pressures, we emphasize this. The absolute pressure. Especially when we're dealing with gaseous transformations, we must use absolute pressures. It's important to keep this in mind. In this video, we'll see how to measure effective pressures or pressures. When we deal with liquids, the easiest way to do it is using piezometers. In this figure, we see a pipe that links a reservoir to a closed valve. The system contains a liquid whose specific weight is gamma. The pressure on the free surface of the liquid in the reservoir is 0. If we install a transparent tube on point P, the liquid will ascend inside it until its level reaches the level of the reservoir. The height from the point P to the liquid surface in the tube is equal to effective P at P over gamma, or in short, P at P over gamma. That's how we'll write it from now on. We use transparent tubes like this in many practical applications. They are the simplest type of piezometer. As we've seen in other videos, the height P at P over gamma is called pressure head. Knowing its value, it's easy to know the corresponding pressure. We just multiply the pressure head by the specific weight of the liquid. But a problem may happen. Imagine that the pipe is the suction of a pump. The pressure inside it is negative, so air will be sucked through it. Well, in this case we use a U-tube manometer like this. Of course, it can be used for positive pressures too. We'll change this three-dimensional representation for this one. It's the cross-section of the pipe. It will be more useful for the cases that we'll study from now on. Manometers like this are also called liquid column manometers or liquid manometers. We make this distinction because there are also metallic manometers that we'll see in the next video. But let's get back to the subject of this video. As we've seen, our U-tube manometer can be used for positive pressures. The pressure will be P equals gamma H. And for negative pressures, the pressure will be P equals minus gamma H. There are cases in which the pressure is too small, so the height is difficult to be measured. So, the transparent tube is inclined, and we read L instead of H. The pressure will be P equals gamma H equals gamma L sin theta. It's important to know the pressure inside the pipe is always taken with respect to x-axis. Let's solve an example. A fluid whose specific weight is 8,500 newtons per cubic meter flows inside the pipe. There is mercury inside the U-tube manometer. The mercury specific weight is 136,000 newtons per cubic meter. What's the pressure inside the pipe? By Stevens' law, we can write P at P equals PA plus gamma H1. And PQ equals gamma mercury times H1 plus H2. As P and Q are inside the same fluid at the same height, we combine the expressions. And, substituting the values, we find PA equals 119,850 pascals, or PA equals 119.850 kilopascals. Let's solve another one. A U-tube manometer containing mercury is installed at the suction pipe of a pump. What's the pressure inside the pipe? This one is easy. Considering this side of the U-tube, we know that PB equals PA equals 0. But PB equals PC plus gamma mercury times BC bar. So 0 equals PC plus gamma mercury times BC bar. Thus, PC equals minus gamma mercury times BC bar. Let's call it expression 1. Now, considering this side of the U-tube, we also have PD plus gamma times CD bar equals PC. So, PD equals PC minus gamma times CD bar. Substituting 1 in this expression, we find this expression. Knowing that CD bar equals 0.2 meters plus D over 2 equals 0.2 meters plus 0.2 over 2, CD bar equals 0.3 meters. And we find PD equals minus 57,400 pascals. Let's see what happens in an inclined tube manometer. What's the pressure at the point P shown in this figure? Piece of cake. P at P equals PA equals gamma oil times AC bar times Sane 30. So, P at P equals 8,000 times 0.20 times 0.50 equals 800 pascals. It may be interesting to use different immiscible liquids in our liquid manometers. For example, we use mercury to measure great pressures because its high specific weight leads to smaller liquid columns in the manometer. In the case of this manometer, starting from the free surface, we can write 0 plus gamma 2 H1 minus gamma 1 H2 equals P at P. So, P at P equals gamma 2 times H1 minus gamma 1 times H2. In this very complicated situation, knowing that gamma I equals gamma water times delta I, the procedure is the same. Starting from the free surface where P equals 0, we write 0 plus gamma 5 times Z5 plus Z4 minus gamma 4 times Z3 plus Z4 minus gamma 3 times Z2 minus Z3 minus gamma 2 times Z1 minus Z2 plus gamma 1 times Z1 minus Zp equals P at P. So, P at P equals gamma 5 times Z5 plus Z4 minus gamma 4 times Z3 plus Z4 minus gamma 3 times Z2 minus Z3 minus gamma 2 times Z1 minus Z2 plus gamma 1 times Z1 minus Zp. See? It's fun! I love it! What about you? Leave your comments. I really want to know your opinion. Okay, another one. This device contains 3 immiscible liquids of different densities as shown. What will be the pressure in the manometer? We can see that PA equals PB. Starting from the free surface, we find this expression, and starting from the manometer, we find this expression. But PA equals PB, so we can put together the expressions and find this result, or even better, this result. Knowing that gamma water equals 10,000 newtons per cubic meters, we substitute the values and find the pressure that we wanted, 2,900 pascals. Easy, very easy, isn't it? I told you it would be fun. In our next video, we'll talk about differential manometers and metallic manometers. See you there! Oh, and if you like this video, don't forget to give it a like, comment, share, and subscribe. Hit the bell so you can be notified of my next videos.